In this example, we're asked to integrate 1 over x squared minus 4 to the 3/2 power with respect to x. Now, I know I've been going on about how you use trigonometric substitution when you're integrating a sum or a difference, so addition or subtraction under a square root. There is a square root in this problem when you interpret this 3/2 power as power over root. So it's the third power and it's the square root. So we have square root of x squared minus 4 within this problem. And a simple u substitution, so u equals x squared minus 4, won't solve this integral. Because if u is equal to x squared minus 4, then du is 2x dx. We don't have an x to multiply by the dx here. And we can bring in a multiple of 2. That's no big deal. We can put 1/2 outside. We can't bring in a multiple of x. That won't work out for us the same way. So we decide to use trigonometric substitution. Now we have to decide, okay, so what trig function should I use to replace the x in order to make this something that simplifies nicely so I can integrate it. So over here, I have that menu of trig identities that we use with trigonometric substitution. So these are the 3 that come in handy when you're applying trig substitution. Now, if you're comparing that, I gotta get out of the way, with the x squared minus 4 expression here, remember that the trig function is going to replace x. So we want the identity that puts the trig function in front minus a constant. So we're going to use this third identity in this problem. Now, if we did a straightforward just let x equal just secant of theta, then notice that that would give you secant squared theta minus 4. And secant squared theta minus 4 isn't anything. Like, we can't simplify that. So we need the 4 to factor out. The way to make that happen is to let x equal 2 times secant theta. That way when you square it, you'll have 4 secant squared, and so the 4 will factor out. So this is the substitution that we want. Now remember, as soon as you choose a substitution, so 2 things about this, I know I've said it before, but make sure you use a different variable here. Don't write x equals 2 secant x, because that doesn't make sense. And don't forget to convert your differential. So if you're going to change x to this trig function, then that's also going to change your dx. Dx then will be 2 times the derivative of secant, which is secant theta times tangent theta. And now I'm going to make that replacement inside this integral. So that turns this integral into 1 over, I'll go ahead and write this 3/2 power as the square root cubed. So square root cubed of x squared. So x is 2 secant theta. So x squared would be 4 secant squared theta minus 4 times dx, which is 2 secant theta tangent theta, d theta. Now I want to simplify. I'm going to work on just this radical expression here without rewriting the entire integral, just to save some rewriting here. So this expression in the denominator is equal to, well, let me not forget about, so it's a square root cubed, but what's under the radical, so in here we could factor out 4. And if you factor out 4, you'll have secant squared theta minus 1. And secant squared theta minus 1 is equal to tangent squared theta. So this is equal to the square root of 4 times tangent squared theta, all cubed. So if we take the square root, that's 2 times tangent theta, all cubed. And so it's 8. 2 cubed is 8, tangent cubed. Okay, that's the denominator here. I didn't want to have to write the entire integral for each step of that process. So coming back to the integral overall, so we have 1 over, and we just simplified that denominator to 8 times secant, not secant, sorry, tangent cubed. 8 times tangent cubed times that dx. So 2 secant theta tangent theta d theta. Okay, so now comes the fun part. We can reduce. And this doesn't, I guess I got overexcited. This doesn't reduce a whole lot, does it? So we can cancel a tangent. Okay, so that's tangent squared now in the denominator. We could reduce the 2 over 8, so the 2 cancels here, leaves a 4 in the denominator. Okay, so this becomes 1 over 4. I'm going to move that coefficient out front. And then, so what's left? Secant theta over tangent squared. Secant theta over tangent squared theta. D theta. Just double checking. Secant theta, tangent squared. Yes. So something like this. This isn't your traditional secant tangent integral where we say, okay, well, do I want to break away a secant squared? Do I want to break away a secant tangent? That's not really what's going to work here when the tangent squared is in the denominator. And that's not really tangent squared, that's cotangent, right? Reciprocal of tangent is cotangent. So this is more like secant theta times cotangent squared, which secant and cotangent don't have like a relationship as far as derivatives go. So something like this, your best plan of action is to write that in terms of sines and cosines. So that numerator, the secant, let's see if I can save some rewriting on this. So secant here is equal to 1 over cosine. Oops. 1 over cosine theta. And tangent in the denominator, or tangent squared, is sine squared over cosine, right? Because tangent sine over cosine, so tangent squared is sine squared over cosine squared. So I'm going to write this as 1 over cosine theta times the reciprocal of what I've written in the denominator here. I have that fraction in the denominator. I'm going to bring it up, flip it over, so this is times, because like I said, it's actually cotangent squared, so it's cosine squared over sine squared. And so that can be simplified. Cancel a cosine, d theta here. And so now you're integrating cosine theta over sine squared theta. That can be integrated using a substitution. So I was hoping to fit it on this board. I don't know if it's going to happen or not. Let me see. I'm going to get rid of this previous step here. Then the substitution that we could use here is let u equal sine of theta. Because if u is sine of theta, then du, derivative of sine, is cosine theta. D theta. Which is right here. Cosine theta, d theta. That's du. So then, this integral actually has the form 1 over u squared, so that's u to the negative 2, times cosine theta, which is du. So the antiderivative, I must have missed something earlier. Oh, no, I didn't. Okay. Antiderivative would be u to the negative 1 over negative 1. Right? I'm going to just come to the top of the board. Stop putting this off. Okay, so I need to keep that fact on the board. But let me come back to the top. So we've got the integral of u to the negative 2. So apply the power rule to find the antiderivative. That's u to the negative 1 over negative 1. Right? Plus c. Okay, so we've got it integrated. Now we've just got to untangle this because we went from x to theta to u. We've changed variables twice actually in this solution. So getting back to x. First I just clean this up. So I'd put the negative out front and then u to the negative 1, so that's 1 over u. Okay, but u is equal to sine of theta. Yeah, I did miss something earlier. So that's negative 1 over sine theta, plus c. So that's negative cosecant theta. I must have said something incorrect back here. Wait, I want to take another look at this real quick. So we had secant theta over tangent squared theta. And so I said that's equal to cotangent squared times secant. Oh well. Let's see. I just want to double check because I'm a little surprised how this is working out. It looks good. Yeah, we're fine. Okay. Negative cosecant theta. Now we have to get it back to x. So getting from theta to x hinges on this equation right here, which I'm going to write as, so divide both sides by 2, x over 2 equals secant theta. I'm going to use a triangle to translate that to an expression of x for cosecant theta. So secant is the reciprocal of cosine. So the old SOHCAHTOA, if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. So if we draw a triangle with those labels, here's theta. Let me get rid of all this extra stuff here. Hypotenuse is x, adjacent side is 2. Use Pythagorean theorem to find the third side. So I'm going to call this, I'll call it y. Then the square of the two legs, so 2 squared plus y squared is equal to the square of the hypotenuse, x squared. And we want to solve for y. So y squared equals x squared minus 4. And so this y right here is equal to the square root of x squared minus 4. Then cosecant theta, it's the reciprocal of sine. So this is, sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. Once you have the three sides of the triangle labeled over there, you can write any trig function of theta, any trig function evaluated at theta. So in this case, cosecant of theta, just use the sides of the triangle. So that's hypotenuse x over opposite side is the square root of x squared minus 4. And there's your final answer.